right? Yeah. Yeah, we will start soon our lecture. Okay, because I let you have the break already, right? And M604 has finished it quite earlier, right? Oh, sorry. No, no, no. Wait. Yes. Okay, when everything is fine, we are gonna start our lecture right now. It's something about the talk. Okay, talk is also known to you earlier as the moment, right? The moment in physics, right? Moment is the force multiplied by distance, right? It's the product between the force and the moment. Okay, in yeah, you could get the outcome, the force and the distance, and you get the outcome as the the moment, and it is also known as torque. Okay, in realistic application, for example, in engineering, we would say it's torque. Okay, but actually, it corresponds to the quantity in physics, which is known as the moment. Okay, moment is the product between the force and the distance. All right, I hope that everything is fine. Okay, I have to send, but that channel is not so strong. I think it's not so smooth. But anyway, if you want to see it, but the channel that is transferred from the Zoom will be the best case. Okay, if you don't want to stay in Zoom. Right นะครับอัพพิมพ์เริ่มพิมพ์ชื่อนะครับที่ในแชทนะครับที่แชทของมันอาจจะไม่ค่อยสมูทนะครับในช่องนี้นะครับyeah, you can start typing your name in the chat box in the Zoom. All right, and we would มาครับคนนะครับ we will start soon our lecture on page 108. Okay, the new story to us is on 108. Okay, and I have to share the file also to you, right? This one SMS the M604. All right, PDF, right? Yeah, is that correct? I would need to send it to you. Yeah. Now let's continue our story. This is the new topic, which is talk on a current loop. We still have few topics to go ahead in order to complete this chapter. Yes. Rồi. Anh đi share những cái nào anh share okay. Link send to you M605 right in everything. Okay, every person export right. Yeah, we have a conductor and we leave it in a square shape, okay, but we can't send it. I'm going to use the wireless link. X1 X5G in this one M605, right? Because the file is quite large. All right, and now here we will talk about our story. ฝนตกนะครับใช้ Wi-Fi กับกดสัญญาณในเน็ตมันจะเจ๋งนะครับ Alright, here are the square shape, right? The rectangle shape. I'm sorry for that. It's a square shape, and we will see what is going on with this square shape if we have a magnetic in that area, magnetic field, right? The vector B, as you can see here, the green one. All right, and this is the square shape, but it's the ideal. Okay, the most possible way is that you have the input side, okay, and the output side. Okay, the input side and the output side like this, okay, and you let the current flow in this direction, okay. You can connect it through any water source. It's for simplicity, it's gonna be direct current source, okay, like that. Okay, it can be a direct current source like this, okay. You connect the positive side or the positive polarity to one conductor, and it start to connected to this it is further connected to this conductor wire, right? It can be made of aluminum, copper, or any type of metal. All right, and that's the case for us. Yeah. Yeah, the currents will flow in this direction. ถ้าใครผมลืมกดให้เข้ามีอีกไหมครับมีไหมไม่มีนะครับก็เหมือนเดิมนะครับพิมพ์มาที่กดที่ตรงไหนที่ตรงนี้นะครับก็คุณก็พิมพ์มาอย่างนี้นะครับพิมพ์ชื่อมาเหมือนเดิมเรานะครับเพื่อไม่ให้ประหยัดเสียเวลาครับโอเคyeah, our story is here. All right. Yeah, the currents start to flow at the input side here, okay, but the important thing is the square shape, the rectangle shape of the whole conductor. The current will flow from this one, okay, from the upper side of the rectangle. It start to be to flow along the left side of the rectangle shape of the conductor, and at the same time there is magnetic field. Okay, for any source, I don't know, it can be from conductor of that's the magnetic field on Earth, but the magnetic field on Earth is quite light, it's not so strong. Okay, so yeah ผมแชร์ไฟล์ที่ Good Notes ไปให้ด้วยนะครับเผื่อมันอัปเดตแล้วคุณอยากจะเขียนจะแก้คุณจะถามผมแล้วแบบว่าต้องการวาดรูปอะไรอย่างเงี้ยนะครับโอเคไหมคุณจะวาดรูปให้ผมดูผมคิดอย่างนี้ได้นะครับโอเคไหมคุณก็วาดรูปไฟล์มาแล้วก็เปิดเทียบกันครับเพื่อว่าไฟล์จะได้อัปเดตเผื่อคุณอยากถามนะครับมันอยู่ไกลกันก็ต้องใช้เทคโนโลยีใช้วิธีสื่อสารทางเทคโนโลยีแบบนี้นะครับพยายามทำให้ได้มากที่สุดเท่าที่ผมรู้เรื่องนะครับโอเคไหมครับyeah that is magnetic field which is denoted by the green arrows here. Okay, from left to right. Okay, it's directed horizontally like this. Okay, and because we are quite far from the source of the magnetic field, the line here, the magnetic field lines are parallel. Okay, to each other, and it's uniform. Okay, there is no spatial density of magnetic flux in each location. Okay, all the area here will receive the same amount of magnetic field เสียงใช้ได้นะครับโอเคไหมผมเทสดูก่อนokay that's okay เสียงใช้ได้อยู่that's the first or the more the simple assumption we have to apply to assume. Okay, otherwise we will get trouble, and when the magnetic field is not uniform, it will be beyond your scope. Okay, we need to use the calculus, especially the integration. Well, สำหรับคนที่ขอนะครับเดี๋ยวเตือนผมด้วยนะว่าอาจารย์สรุปเป็นภาษาแต่อย่างนี้6 โมงเย็นนะคุณ605คุณเตือนผมด้วยนะก่อนที่จะยกเลิกคลาสบางทีผมอาจจะลืมว่าเขาเขียนมาบอกว่าให้สรุปเป็นภาษาไทยให้ด้วยความยินดีเลยครับโอเคไหมแต่เวลาอาจจะเลยนิดนึงหรือว่ายังไงก็แล้วแต่ครับคนที่จะควิดคุณจะเลิกก่อนก็ออกไปก่อนได้นะครับโอเคไหมแต่สำหรับคนที่อยากจะฟังสรุปภาษาไทยผมจะพูดให้นะครับโอเคไหมสำหรับเลคเชอร์ในแต่ละครั้งครับ605นะครับเพราะว่าคุณไม่มีเวลาเป็นข้อจำกัดนะครับหลังจากคุณไม่มี60อะไรต่อไปนะครับไม่เหมือน604นะครับ alright here you have the magnetic field moving through this rectangle conductor. In yeah, the current will flow in any way as they could go. Okay, there is no other connection, so there is only connection to the right. It's gonna the current is going to move like this. Okay, actually electron, but in the opposite direction, and it moves further upward like this, and it returns and get back out of the whole area here in this direction. Okay, it reaches the negative side or negative polarity of the source. Okay, but they don't talk about that. But this is the whole detail, whole story of this thing. All right, let's say the short side. Okay, the short side of the rectangle is of the width a. Okay, and the long side of the rectangle is of the length b. Okay, that's a typical shape of the rectangle. In yeah, as you may have heard before, we have studied or we have considered the story about F equal ILB, right? F ILB, right? That's the formula in order to determine the induced force direction, right? For example, if you have L here, right, in this direction, and you have B here in this direction, right? Just the step is that the technique is that you have to start from the first vector, the direction of the vector L, to the second vector, which is vector B, and you curl or rotate your 4 fingers from the first vector like this, and your thumb direction. Okay, that's the most important thing. The thumb direction to to this rotation is gonna give you the direction of the induced force vector F. Okay, according to this formula. Okay, don't talk about. Don't pay attention to I. I is only the magnitude of the vector L. Okay. Yeah, that's the thing you have seen before, right? In let's take a look at this I, right, and B. You will find that ILB sine theta. Okay, the scalar version of this expression is FILB sine theta, right? Sine theta or sine phi, up to you, right? Theta is the angle between vector L and vector B, right? Because that's the result from the cross product of two vectors. And you would find that when I is moving like this and B is moving like this from left to right, this one from right to left, the angle between them is gonna be 180, right? This the combination of these two vectors, it's 180, and you will find that sine of 180 is sine 110 เท่าไหร่สาย110ทะเลนะมันคุณเรียนวิชาคณิตศาสตร์มันต้องใช้ด้วยครับที่นี่นะครับเห็นไหมมันเกี่ยวข้องกับฟิสิกส์ด้วยแล้วก็นู่นครับใช้ถึงปริญญาตรีปี3ปี4นะครับเห็นไหมจนsine of 180 is gonna give you 0, right? So it means there is no force at all in this location เชิญครับก็ไม่เป็นไรครับไม่เสียหายไม่เป็นไรครับตามสบายเลยครับคุณดูที่หน้าจอนะครับเข้ามาที่แชทลิสต์ตรงบ็อกซ์ตรงซูมนะครับตรงเนี้ยครับตรงเนี้ยที่เพื่อนๆเขาพิมพ์กันเห็นไหมครับเนี่ยคุณหมายเลข20ใช่ไหมผมเห็นคุณ20แล้วก็ชื่อแรกนะครับแล้วก็ชื่อวาเลนทอนเรียบร้อยครับแค่นี้แหละครับโอเคไหมครับด้วยความยินดีครับดูที่ไลน์กลุ่มของห้องผมส่งให้2ลิงก์นะครับมี2อันนึงที่ภาพชัดๆมันจะกระตุกผมส่งให้ไหมไม่ส่งให้โอ้ my god I'm sorry for that oh sorry I didn't send you the link in the YouTube ผมไม่ส่งเหรอส่งหน้าผมก็ว่าส่งอยู่นะส่งให้อีกรอบหนึ่งครับไม่รู้ใช่หรือเปล่านะส่งแล้วเนาะโอเคมันมี2ช่องครับคุณเลือกเอาช่องที่คุณดูแล้วสบายตามที่สุดเพราะว่าอินเทอร์เน็ตมันไม่แรงครับTrue เขายังไม่มาเดินสายไฟเบอร์ให้ผมนะครับอันนี้เป็นตามสบายครับคุณเช็คชื่อในแชทในซูมแล้วคุณก็ออกไปที่ YouTube ก็ได้หรือว่าคราวหน้านะครับคุณบอกว่าคุณไม่อยากเข้ามาในซูมคุณอยู่ที่ YouTube ตรงหน้าไหนก็ได้แล้วคุณพิมพ์ชื่อเคาะลงไปในแชทในไลฟ์ของ YouTube นะครับแล้วคุณก็แคปเจอร์หน้าจอนั้นนะครับมันจะสแตมป์เวลาอะไรของคุณด้วยนะครับแล้วก็ส่งเข้ามาในไลน์กลุ่มนะครับเพราะว่าเสร็จหลังจากนี้ผมจะได้ลงคะแนนเข้าเรียนให้คุณนะแล้วผมก็ต้องแจ้งอะไรหัวหน้า EP อะไรของนะครับแล้วก็ส่งให้คุณด้วยนั่นแหละโอเคไหมครับแจ้งคุณครูโคอะไรประจำทุกครั้งอย่างเงี้ยนะครับโอเคไหม alright so let's get back to the detail of our story in the upper part of the square rectangle you have side 180, right? There is no force exerted on this portion, this part, this component at all, okay? And on the upper part of the rectangle. But what about this? The left side. On the left side, you have the vector L like this, right? That's the vector L. And vector B is gonna be like this, right? This is the vector B, all right? And in the typical way, we have to rotate our 4 fingers, okay? Except for the thumb, okay? You rotate or you curl your 4 fingers from the first vector, which is vector L, right? According to this formula, from the first vector to the second vector, which is vector B, right? And you will find that your thumb direction will give you คุณห้ามดัดมือพิเศษนะเอามือแบบธรรมชาตินะครับโอเคไหมห้ามนิ้วแบบลำไทยนะครับโอเคคุณกำมือธรรมดาโอเคไหมครับ your 4 fingers will it gives you the thumb direction like this, and its direction of the thumb is going to point out of this plane, and we get the dot symbol here, which represent the head, okay, or the front view of the arrow or of any vector, right? Everywhere here you get the force out of the plane of this lecture note or your monitor, right? You will get all the force in this components, okay? And what about this? The lower component, what is expected? What do you think? Whether we should have the force on this component or not คุณคิดว่ามันจะมีแรงเกิดขึ้นไหมข้างบนไม่มีแรงแล้วไม่มีแรงเกิดขึ้นนะเพราะว่า sin 180เป็น0 What do you think here? Whether we will have the force in this one or not? What do you think then? คิดว่าเป็นอย่างไรครับ Of course, it's the typical way if you use the I'm sorry, if you use the conventional way ILB sine theta, you will find that at this component, the lower one, you have vector L pointing like this. Okay, that's the vector L, and of course again we have vector B in this direction as well. Okay, that's the vector B. So the angle between vector L and vector B is 0, right? So when there is no angle at all, so it means 0 degree of angle between B and L. So sine of 0 is gonna be 0. So there is no force happening on this bar at all, right? There is no force here, and also no force here, right? We internet problem นะครับ Use this one. Okay, let's move to the last part, which is this one, the vertical one, and we can see that ไม่ทราบว่าสัญญาณผมดีหรือไม่ดีนะครับ you can see that here we have vector L directed in this direction. That's the vector L, right? And the vector B is gonna be here, right? Pointing from left to right. All right. And yeah, we have to follow the same manner. We start from the first vector to the second vector, right? We rotate our our 4 fingers from the first vector L to vector B. You will get the outcome, okay, on the left side of this equality, which is the vector F, okay, the induced force on this component, okay, this bar. And you will find that your thumb direction will point downward or into this plane, right? And in order to draw 3-dimensional in อย่างรวิพลครับรวิพลก็พิมพ์มาที่ YouTube นะครับก็เดี๋ยวผมแคปเจอร์กันเหนียวไว้ด้วยนะครับก็คุณก็แคปเจอร์แล้วก็ส่งหน้าจอนะครับถ้ากลัวพลาดนะครับถ้ากลัวพลาดก็แคปเจอร์หน้าจอแล้วก็ส่งมาในไลน์กลุ่มด้วยก็ได้นะครับ alright, and that's it. And yeah, the force here, okay, will be directed into this plane. So what we can see in 2D is that we can see only the rear part or the tail of that vector of that arrow. So we write down the X side or the cross side here. All right, that's represent the tail of any vector, right? We have here the dot, that's the front view, okay, the front side of the vector, right? that's the front side, and the cross side, okay, the x side is the rear side or the tail, right? Rear side คือด้านหลังของเวกเตอร์โอเคไหม rear side of that vector. All right, for any vector, right? But here the main interesting quantity for us is the vector f, right? Okay, you will have all vector f pointing downwards on this bar. Okay, the vertical bar on the right side of this conductor, like this. Okay, pointing down, pointing upwards. So what happens if we have the force that try to keep this one up, okay, and the force that try to make this one down? What do you think? There is no force at all along this component here. Okay, there is no force acting on these two bars, but there are two group of forces acting on the left and the right side. What do you think then? Of course, ขอใช้กล้องno oh sorry for that. How could I oh no, my god. Okay, in right direction. Alright กลับไปอีกรอบนะครับ อินเทอร์เน็ตหลุดนะครับมันฝนตกนะครับ alright yeah, if not we're gonna replace this one, okay, by using only the same card. And yeah, here is the technique. Is that all right? ใช้ได้ไหมครับ okay, here BSK. All right, okay, you have the force, right, like this, and yeah, one try to keep this side up, and one tries to another group of force try to bring this one down, right? ขอเช็คเสียงก่อนครับว่าเสียงยังมาอยู่หรือเปล่า alright มาอยู่นะครับhere one try to keep this bar up and one tries to keep this bar down, okay, make this down, so there will be rotation to this one, okay, to this conductor loop or bar, okay, if we take a look at the side view of that conductor loop. All right, and that's the case is the case that is going to happen. ผมก็ไม่รู้ว่ามันหลุดไปตอนไหนนะครับมันใช้ทั้ง Wi-Fi ใช้ทั้งอันนี้นะครับyeah, let's get back to our lecture notes. We move to the figure 48, okay, on the next page 109, and here is the side view, okay. What is the side view when I often say side view? Okay, let's get back to the zoom again. Okay, side view, what is that? พูดเป็นภาษาไทยแล้วกันนะครับกล้องเห็นนะครับโอเคalright ไหนดีside view แก้วอันนี้แล้วกันกาน้ำนี่แล้วกันครับเห็นไหมครับกาน้ำครับทุกคนเห็นนะครับถ้ามองด้านข้างครับคุณก็จะเห็นเป็นรูปทรงอย่างนี้เห็นไหมเห็นเป็นรูปโค้งมีรูปดูด้านข้างมันก็จะเป็นภาพ2มิติของมันใช่ไหมมันจะมีรูปโค้งรูปปลาของกาต้มน้ำแล้วก็มีฝามันนะครับถ้าคุณเปิดฝามันก็จะ ก็จะเป็นฝาเปิดอ้าอยู่อย่างนี้นะครับโอเคไหมแต่ถ้าI'm not sure whether you can see it properly all right yeah no all right yeah นี่ all right yeah ถ้าคุณมองเฉพาะด้านข้างครับคุณก็จะมองเห็นรูปทรงมันแบบนี้นะครับแต่ถ้าคุณมองด้านบนของมันนะครับมันก็จะเป็นอีกแบบหนึ่งโอเคครับเขาเรียกว่า front view ก็คือ top view นะครับก็คือมองข้างล่างลงไปข้างบนข้างบนลงไปข้างล่างครับแล้วก็ side view ก็คือถ้า side view ด้านนี้ครับก็คือคุณก็จะเห็นด้ามมันนะครับแล้วคุณก็จะเห็นข้างๆเห็นฝาง้างมาแบบนี้นะครับในขณะที่ด้านนี้นะครับถ้า side view แบบนี้คุณก็จะเห็นปากที่ริมนะครับแล้วคุณเห็นฝาของมันที่เปิดค้างไว้นะครับก็เนี่ยด้านข้างแบบนี้นะครับการมองเข้าไปแบบนี้เรียกว่า side view นะเวลาผมพูดนะครับเขียนมามันเป็นมุมมองพื้นฐานนะถ้าคุณเรียนเขียนแบบวิศวกรรมนะครับมันก็จะมี side view top view ก็คือมองบนลงล่างก็อันเนี้ยมองจากข้างล่างขึ้นบนก็มีครับมีหลายมุมมองใช่ไหมแต่ว่าของเราเนี่ยมีแค่ด้านเดียวครับ side view in figure 48 all right if you take a look at figure 48 which is the side view of figure 47 or the previous figure here is the top view of the whole conductor, right? Saying this one is going to be the side view. Okay, if you take a look at you have your eyes like this, okay, and here is your eye, okay, and you take a look at this one to this in this direction, you will see the figure in this way, okay, all right, and yeah, one side of the connector has the force that try to keep it upward, okay, lifting force, and another side of the connector here is the place where you can find the pushing force, okay, the force that try to make this side going down, okay, going downwards like this. And yeah, as I told you in the camera, this bar is going to rotate, okay, and when forget about it. If the force here is pointing up, okay, it means this object is like this one, okay. You have an object and there are two forces. This force F1 and F2. Okay, try to keep this object up, so this object is going to move upward, okay. And if they have M, we are going to apply the Newton law, which is sigma F ma, right? You will be able to determine the acceleration of this mass, right? But this is not the case, because one side has the lifting force and another side has the pushing force. This will give you the rotation of this object, right? นะครับสรรพสิ่งในสเปซในจักรวาลมันก็จะมีเคลื่อนที่ตรงเคลื่อนที่แบบหมุนมีอยู่2อย่างเนี่ยนะครับโอเคไหมวิชาฟิสิกส์ก็จะพยายามอธิบาย2สิ่งนี้ alright, and that's the case. There will be rotation of these one, and as you may have seen in Matheum 4 or Matheum 5, that is the so-called moment, right? Moment, or even in Matheum 3, moment is the product between force and distance, right? The distance that the force is going to take place, okay, distance from the rotating point, okay, which is this one. They use the alphabet O, which represent the origin or something like that, or 0 position, okay. In English, they would say is pivot, okay, P-I-V-O-T. It's the rotating or the referencing point, all right. And yeah, you will have this point as the reference, and of course this is the moment that try to keep the whole object here rotated in the clockwise direction. Okay, this is the clockwise direction, right? And here is the anti-clockwise direction, right? Or the counterclockwise, CCW, right? Counterclockwise direction or anti-clockwise direction. That's right. But the force here is the is the part of the moment to make this object rotating in the clockwise direction. So we would say it's moment in the clockwise direction. So moment is the word known in physics, but in engineering we would call it torque, right? It's torque. All right, it's torque, and it's represented by the tau symbol, tau letter, and it's going to be F1, right? The magnitude of F1 times the distance between the force to the and the rotating point, which is okay. The whole length here is A, right? But according to the symmetry, the rotating point is going to locate at half the whole length here. So this one, okay, the distance from the first force to the rotating part is going to be A by 2. So F will be the multiplication, torque will be the multiplication of F1, okay, the left side, to the distance that you have the force, okay, with respect to the rotating point is going to be A by 2, right? But it's not only the one source of moment, okay, there is another moment as well, and it's in the same direction. Okay, if this one is pointing up, okay, we're gonna say it's negative. Okay, but when it's the accumulation, okay, the summation here, okay, because it just increase the moment in the same direction, so it's going to be plus. Okay, as we know before, a moment is a force multiplied with the distance. So it's the name of the force on the right side is F2, right? F2 times the distance. Okay, because of the symmetry, the distance here is again A by 2. All right, here that's the way you have for this figure. All right ผมเป็นอะไรผมขออนุญาตเข้าห้องน้ำนิดนึงครับเดี๋ยวกลับมาต่อเวลาให้ก็ได้ครับ All right. Okay. Let's get back to our story. That's the case when the conductor loop in rectangular shape laying like this. Okay, and of course, if you go further, you find that a by 2 is the common term, right? They both are the same, are of the same value, so we have a by 2 and f1 plus f2. All right, but if you go further, you will find that f1 and f2 actually have the same magnitude. Okay, f1 and f2 will have the same magnitude. You will see the detail later. And let's say f1 and f2 is equal to f, okay, without any subscript. You get a by 2 and here 2f, right? And of course, number 2 here will cancel each other. You will get a times f, right? Yeah, it's quite simple. A is the length of the conductor here, right? F is the amount of the magnitude of the force on each side, okay? And F can be found later if you can remember the story that we have talked earlier, right? It's F is equal to ILB sine theta. And what is theta actually? Theta is the angle between L and B, right? Vector L and vector B. So that's the case, okay? Here it's general expression in terms of F. But what is the situation when we have, of course, this object is going to rotate in clockwise direction. And what is the torque at the moment where we when the bar is tilted? Okay, it's not simply laid on the plane like this. Okay, it's tilted a little bit by angle theta. Okay, theta here. All right, and let's see what is going on with that. Yeah, you will find that theta here is measured is the angle between the normal vector of the plane to the magnetic field. Okay, and so let's me give you the idea of what the normal vector is. Here you have the plane, right? ภาษาไทยเรียกว่าระนาบ okay ไหมครับ okay, you have the plane and the normal vector is the vector that is start or directed out of this plane, and the special thing of this vector, which is unique, okay, which is distinct from any vector. Okay, you can have any vector this direction. Okay, there are many vector, there are many possible way of vector, but the red one here is the single and unique vector that has angle of 90 degree in any direction. Okay, this is 90 degree, this is 90 degree in any direction to that plane. Okay, and this one is called normal vector. Okay, the vector that is perpendicular to the plane. Okay, sorry for that. Normal vector. All right. Yeah. The angle theta is the angle between the plane normal vector to the magnetic field. Okay. And yeah, FILB sine theta in that expression is different. It's the angle between L and B, but in this one they use the same alphabet, but the value of theta represents a different thing. It's the normal vector, a normal line to the plane. Okay, you can see here a normal line. The angle between these one is 90 degree. All right, here as well is 90 degree. Okay, that's the normal line or normal vector. Well, yeah, at the moment when the conductor loop is tilted, okay, is bent a little bit, is tilted actually, is at the location of angle theta like this. All right, and what is the torque that happens in this scenario? Of course, the definition of the moment or the torque is the force time distance, right? But at this moment, but the important thing is that the force and the distance you measure should be 90 degrees or perpendicular to each other. Okay, it does mean that you have F here and you multiply again with A by 2, okay, because the force is not perfectly perpendicular to the loop anymore. Yeah, okay, the force doesn't the force is not directed in this way anymore, okay, because it's lifting force. The force should be all the time vertical like this. All right, it's not this one, okay, it's not this one, not this one. All right, so we have to recompute or compute the moment again, and what we may observe is that this is the distance between the force acting on the rotation, and this is the amount of the force. The amount of the force should remain the same, okay, because the shape of the copper wire doesn't change, okay, it's a rigid object, so the copper wire is not bent, okay, it has the same length, so the amount or the magnitude of the force should be the same, remain the same. In but the different thing is the difference is the distance between the perpendicular force to the rotating point or the pivot here, okay. As they define, okay, theta is the angle between the normal line or the normal vector to the magnetic field directions. So this is theta, and you can see that the reflection of that angle is going to be here, angle theta, and of course this is 90 degree, right? This is 90 degree. The angle here, right? The angle here is gonna be 90 degree minus theta, right? And in this triangle, when you have here 90 minus theta, what is the angle at this corner? What is the angle at this corner? What is the value of this one? This one is going to be 90 minus 90, right? 90 degree minus 90 degree minus theta, right? It's going to be only theta, right? So this is theta, and if we draw a conventional Pythagoras of right angle, a triangle, you have here theta, and we would like to know the distance here. What is this value? And here we know that this one is A by 2, right? So this side, okay, this side is going to be A by 2 psi theta, right? And that's the case. All right, it's nothing surprising to us, okay, just a simple Pythagoras theorem. In yeah, you know now that the distance here is A by 2 psi theta, right here, okay. And we get back to the moment computation force, the force that is perpendicular to the measurement of the distance times the distance. So we have right now torque is going to be force should be the same F1, right? But the distance to compute the moment now changes to A by 2 and psi theta. All right, that's the on the left side, and on the right side you have the another f, which is f2. Okay, but if you go further, you find that f1 and f2 have the same magnitude, and of course the distance to compute the moment is this one, right? It's no longer a by 2 anymore. Okay, and if you project everything, you'll find that distance here will be the same as the distance here on the left side, and of course it's going to be again a by 2 sine theta, right? That's it. And of course we have two sources of the moments, so we have to add them together, and it's positive side because it's keep the object rotating in the clockwise direction. Okay, it's accumulation. Okay, it's the addition way. So we have here the plus side f2 times again a by 2, oh sorry, a by 2 sine theta, right? And of course a by 2 sine theta is the common factor. You have a by 2 sine theta now plus f1 added to f2, right? And that's the result. And if you go further, you find that f1 and f2 are equal in magnitude, so this is going to be 2f, right? A by 2 sine theta and 2f. What is the result? Then we're going to have the cancellation of number 2's at both positions, so we get a times f and sine theta like this. Okay, what is the difference then? Here we have AF, right? Torque equal AF. Okay, when the angle between the normal vector and the magnetic field is right angle is 90 degrees, and when the normal vector of the plane is made with theta, angle theta to the magnetic field, we're gonna have AF sine theta. Okay, not simple number one here. And yeah, this is the derivation. If you go into the detail, you find that ILB, what is that? This is the length B, right? The left side, and the right side here is the length of the rectangle side, which is B, right? The long side is this B, right? And I, of course, I is the current, the magnitude of the current flowing in this way, right? ILB. L is B, right? The length of the component of the conductor that has the force, right? Are those two vertical bars. So the length of this one is B, right? And B is the strength of the magnetic field, right? It's going right there, right? B, right? So if you substitute it into FILB, right? Actually, ILB sine theta also, but theta is different way. It's the angle between the length, the vector L and vector B. So in this case, you find that it's 90 degrees. So there is no sine term at all here. It's simply number one. So IB, B, okay, I small b and I capital B, and you substitute it into the original expression, and you will get number 2, factor 2, okay, in front of that, and 2 and 2 will cancel each other, and what you will find is that the product between A, okay, what is the problem? Any internet connection to that or what? Yeah. If nothing is no error happens, so we're going ahead. You will arrive at the term A times B. Okay, A times B. A times B, what is that? Of course, we have the rectangle like this, right? And oh, sorry. Here is of length A, right? And on this side we have the length of B. Okay, and the long side B. On the short side A. Okay, and you may get to know already in your primary school, this is the area of the rectangle โอเคก็คือพื้นที่ของสี่เหลี่ยมผืนผ้านะครับโอเคไหม so AB is the area of this rectangle and it means that we won't express it in terms of small a and small b anymore. Okay, we simply say it's the area of that of this conductor that occupies. Okay, this the blue one is the conductor. This conductor occupies the area like this, a rectangle. Okay, and we would have AIB sine theta, or you may say it's BIA sine theta. And some of the physicists have defined it quantity which is called mu. Okay, mu, the Greek alphabet, which is the coefficient. Okay, in order to get the torque. All right, it's simply the product between current and the area of this conductor. Okay, the area and the current flowing in that conductor, right? So you can say it's a b I sine theta. Okay, RB, you can say it's RB. I don't know which way you are gonna use to remember, or you prefer this one, I B A sine theta. Okay, any term, any form of this is going to give you the same result. Okay, because there is no order in multiplication. Okay, there's no order priority in multiplication. Okay, any sequence of this multiplication will give you the same answer, the same quantity. Or you would say it's BIA sine theta. Okay, please pay attention to this because this will serve as the basic, because there is another more complicated topic about that when we have several turns of the conductor. Okay, many numbers of the turns of the conductors. So you may prefer try to remember this formula by saying that RB sine theta, or E bar sine theta, or BR sine theta. But for me, I prefer the word BR. Okay, because we are going to have N later. Okay, during my high school time. Okay, I have also attained a special school. Okay, apart from